Good evening, Professor. This is my fourth assignment of MMIC IPD, and today I am going to present my fourth assignment. And in this assignment, the topic of this presentation is design and fabrication of RF design device and using IPD technology. And the first topic in this is IPD design flow. In this IPD design flow, there are 5 kinds of IPD: AWOL, WLAN, LPF, and LTEPF, and WLAN blown, and LTE power divider, and RFID directional coupler are used to design this design and fabrication. In this first I'm going to explain this diagram, what how it is designed and what steps are has been taken, how this IPD design is workflow. I'm going to explain step by step. First is choose the first, as you can see, choose the optimum topology and the right component from the design cell library that match the selected technology, and then perform the design by using software for circular level 2D simulation and physical layout that fits the available space. After the layout, EM simulation employ ADS. Using this ADS software perform in order to optimize this component interaction and wire bonding with the pad and packaging. And the next step is various devices are arrayed and masked and are made for aligning the pattern. Then the designing of the device has been done using fabricated and then the front side fabricated wafer is then tinted using the mechanical polishing CPM, which we called as a CPM method, sewn using the automatically sewn and assembled by die bonding and wire bonding and SOT packaging process. I will explain this in further slides also. Finally, IPDs are subjected to storage test in the high temperature, high humidity, and high pressure environment over a long period of time, and then the measure of their DC and RF performance. Next is topic about low pass filter. In this, as this topic said about schematic circuits and simulation result of design LPF. As you can see in this figure 4.2, first figure is about a schematic and the second figure is about the result of all the simulation has been done. In this next is for more accurate design, LPF was simulated using ADS software, and as you can see in this figure 4.4, the completing layout after completing the layout, the circuit was fabricated using the GAS IPD process, and the next fabricated chip are attached to the PCB using silver epoxy and bonded with a gold wire as you can see in this image picture also 4.4, that has a measurement was performed using the network analyzer using the frequency range of 100 megahertz to 6 gigahertz. And next is again continuing the low pass filter topic. There has been many difference found between the circuit level simulation and EM simulation results. In order to minimize this gap, circuit tuning method being used the internal port using the LPF design, and the insertion loss was typically, as you can see in this picture also, uh, minus 0.56 dB at 2.4 to 2.5 gigahertz, and return loss below minus 27 dB. The attenuation level is second harmonic frequency, which is less than minus 20 dBc. And to optimize this method by using this, the response is quite specific. You get a specific response, as you can see in this figure 4.5, that 2.4 gigahertz WLAN LPF with the die size of 600 meter into 400 meter plus into 200 meters. And next topic is about band pass filter. In this uh, topic, in this it is BPF is a essential device in wireless and mobile communication, as we are aware of this sentence. And BPF exist in RF front end of both receiver and transmitter circuit to reject the noise that may interfere with sensing the transmission. And the configuration was proposed transfer type BPF, as you can see in this figure. The pattern is composed of two indicator and two capacitor, right? The two indicators are intertwined and overlap using 6 air bridges structures, which form the differential transform through magnetic coupling. And next comes the two capacitor are in series of transform termination on the inner surface, and to form the resonance circuit, the two port of impedance or termination are defined as ground. An embedded structure is skillfully introduced to minimize the dimension of the overall circuit. And for the detailed parameter, two inductive metal lines are 15 micrometer width, and the spacing of metal line is 15 micrometer. Now again we are continuing with this band pass filter topic with the simulator result, and what was the simulation and measure result has been done with BPF using IPD process. As you can see in this figure, as parameter results, the center frequency of final fabricated, which is located at 935 megahertz, applied in LTE band 8, and 35 megahertz shift in the frequency due to unexpected tolerance fabrication, wire bonding and die attachment process. And then the simulated and measured result validate the correctness, and the device has the FBW of 85%, and the insertion loss is 1.0 dB, and the return loss is greater than 26.1 dB, and two transmission zeros are released at 2.52 and 5.10 gigahertz with attenuation level of 46.0 and 65 point dB. Okay, this was the attenuation level. And next comes the topic of blonde. It provides the balanced output from the unbalanced input, and this important in double balance mixture. Push pull amplifier has been used, and matching network placed between the antenna and RF front end system, and to balance this output signals, two output signals that have half of the input signal amplitude, and 180-degree are out of phase. And the easiest way to uh, control this and differentiate this phase, it requires a large signal length, lambda upon 2, to achieve the phase differences of 180 to 180 degree at 2.4 gigahertz. And transmission line, this has been created 180 degree and which is out of phase signal, and is small in size, and plumbed indicator and capacitor. This technique used to convert the transmission into plumbed element circuitry, and this made using the relation between the transmission line and plumbed element models. And as you can see in this figure, first figure is about transmission line. As I discuss all the things about transmission line with above points. And B figure is about lump LC, lumped LC. And yes, this continuation with the same topic. As you can see in this figure, 4.17, this is ADS simulation structure, and this is done for more accurate design, and this is done using ADS software. And for completing the layout, the circuit was fabricated using GAS IPD process, and insertion loss of design is affected by the core inductions of L, and the design width of core inductor is about 15 micrometer. Blonde was fabricated and dyed size of 800 micrometer and 5 into 700 micrometer into 200 micrometer. It's RF, as you can see in this what I have said, just the measurement. All this has been done in design of W-lane blonde, and it's a RF performance which is done in the 4.18 figure. This figure is about measured insertion loss and return loss of fabricated when the W-lane has been done. In this figure, in this graph 4.9, it's about measure performance phase of fabricated W1, and the insertion loss and the return loss is about something minus 0.25 dB to which ranges till minus 25.750 dB respective. And this the phase imbalance was less than 3 degree, and its amplitude imbalance was less than 0.5 dB. And next topic is about SOT packaging. SOT packaging of fabricated IPD. As you can see, I have mentioned 4 figure. This in first it is a full view, and the B figure is about side view, and C figure is about top view, and D figure is about front view. In this, the use of semiconductor wafer is cost effective way of simulation fabricated, and all the fabrication and testing is complete and separated from wafer, and assembled into final IC packaging, and assembled and packaging process has been approved electrically device, place them in package and interconnect the device bonding pads to the package leads. Loosely defined, the term packaging refer to the set of technology that connects IC to electronic system, and then the packaging provides mean of protecting the chip from the environment and from handling damage. That is physical support for chip heat dissipation, interconnection of the signals in and out of chip, and for attaching it to high assembly level. And this work, we use SOT packages for fabricated IPD, which are small in size, allow the higher bonded density, leading to the higher electrical speed of for system application. In SOT package, for the chip surface mount plate cat type, which leads to more to longer side into achieve low cost and low profile. So thank you for this presentation, and this was quite a good knowledge about more IPD, and I learned many things. IPD is how IPD design flow, low pass filter in deeply, and how it's working and how simulation is done. So it was great learning this assignment. Thank you.